So in problem one, I look to focus on the mechanical efficiency that we have discussed in class. And with that, it says a student in fluids tried to find the mechanical efficiency of a pump with a power output of about 125 watts. And its calculations proved that its input was equivalent to the output. Therefore, the mechanical efficiency is 1. Are they correct? If not, what would be a more reasonable conclusion? The answer to this would be no, because the student forgot to include the power loss done through work, and a more reasonable result would be a mechanical efficiency of below 1, because the inputted power should be higher than the output of 125 watts, as the mechanical loss would then decrease the total of the power outputted. In problem 2, you turn on your sink to fill up a 30-gallon water bowl for your dog. The pipe's diameter begins at 6 centimeters and reduces to 0.4 centimeters at the nozzle. How long would it take to fill up the 30-gallon bucket with a known mass flow rate of the water being 0.625 kilograms per second? What is also the average velocity of the water? So, in the answer, I follow the KFABS method. The known is the volume, which is 30 gallons, the mass flow rate, which is 0.625 kilograms per second, the diameter of the pipe, 6 centimeters, the diameter of the nozzle, 0.4 centimeters, and the density of water being equivalent to 1,000 kilograms per meter cubed. And what we need to find is the time to fill, which is our delta T, and the velocity exit average. We can assume that the water is incompressible, there's a steady flow, and there's no mass loss, which means no water overflowing or spilling out. So the plan is to find the volumetric flow rate from its relation to mass flow rate and density, find delta T from volumetric flow rate and velocity, and then find the area of the nozzle exiting and use its relations with volumetric flow rate to find the average velocity. The solution. So I take the mass flow rate equal to density times volumetric flow rate. We work it to volumetric flow rate equals mass flow rate over density, which I come out with a 0.000625 meters cubed per kilogram. I then take that velocity, volumetric flow rate, and equivalent it to volume over delta T. The delta T is then equal to 30 gallons over the 0.000625 meters cubed per second that we found in the previous step, and I multiply it by 264.172 gallons per meter cubed to translate to 182 gallons per second. I then find the area by taking the pi r squared of the nozzle, which equates to 0.12566 centimeters squared, and then the volumetric flow rate after doing the velocity exiting is equal to the volumetric flow rate over the area, which then becomes 54,900 meters per second. The value isn't reasonable for a sink. However, the process is still valid.